Hello students, I am Ms. Thandoresis. Today we are going to see IUPAC nomenclature in anionic complexes. Let us see some rules, but before that once again I am reminding to like, share and subscribe my channel if it is not subscribed yet, so that you will get notifications of new videos there. So let us see rules to find out IUPAC names of anionic complexes here. First, you are supposed to write the name of cation there. For example, we'll take one compound. First is write the name of cation. Then write the name of ligand with prefixes di, tri, tetra, etc. depending upon the number of ligands. Write the name of the central metal atom in which suffix ATE is added to the name of metal with oxidation number enclosed in the parenthesis, and you are supposed to write the oxidation number in Roman letter. So let us see one example so that it is much clearer to you. We have seen already the classification of coordination complexes, that is anionic complex, cationic complex and neutral complex there. Anionic complex, that means these are the complexes carrying negative charge of the coordination sphere. That means your counter ion will be the metal and it is present towards the left hand side of your coordination sphere. If the complex is cationic complex, then in that case your counter ion will be non-metal and it is present towards the right hand side outside the coordination sphere. And if your complex is a neutral complex, then it carries that means the coordination sphere carries zero charge there. We'll see today the IUPAC nomenclature in anionic complex. For example, we'll take one example of K4, then Fe, Cn6. This K4 FeCN6 is anionic complex. Why? Because if K4 is removed, that means potassium is removed. Potassium is a metal and it is present towards the left hand side of this coordination sphere. It is present in the ionization sphere, and on ionization you will get 4 K plus ions and remaining part carries a negative charge. That means FeCN6 4 minus is your another ion, and as your coordination sphere carries negative charge, it is an anionic complex. So while writing the IUPAC name of anionic complex, always you are supposed to write first name of the cation. In this case, what happens? Your cation is a potassium, so write just name of this cation as potassium. Then next rule is what? You are supposed to write the name of ligand with prefix di, tri, tetra depending upon the number of that ligand. Here ligand is a cyanide group, CN group, and in case of anionic or complex or negatively charged ions, wherever there is IDE or ending IDE gets changed to IDO or ATE get changed to ATO. We have seen actually names of ligand, how to write names of ligands here. As it is a cyanide, IDE get changed to IDO, and there are 6 cyanide groups, so it is a hexa. Then cyano or cyanido you can write. I'll write here cyanido, and then name of next rule is what? Then you are supposed to write name of the central metal atom in which suffix ATE is added to the name of metal. Here ferrous ion is a present, or ferrous atom is a present as a central metal atom, and ending E get changed to ATE, so it is a ferrate. Then last you are supposed to write oxidation number of that central metal atom, and it is enclosed in the parenthesis. Also you are supposed to write it in the Roman letter. So here your central metal atom is Fe. You have to find out your oxidation state, and you are well known again how to find out oxidation state. For potassium it is +1, 4 K plus ions are there, so it is a +4. Suppose for Fa it is X, then it is 4 plus X. For cyanide it is -1, 6 cyanide groups are there, so it is 4 plus X minus 6 is equal to 0. That means for Fa it is a 2, +4 minus 6 minus 2, and so Fa is equal to X is equal to +2, and hence the oxidation state or oxidation number of Fa is +2. Write in parenthesis and write in the Roman letter. Once again I am reminding let us see how to find out oxidation state. We have seen already, but for your convenience I will show it again. For potassium it is K plus, so +1, 4 potassium ions are there, so it is a 4, plus for Fe suppose it is X, then for cyanide plus it is a -1 for cyanide, 6 cyanide ions are there, so it is a -6, and that is equal to 0. So overall it is what? X minus 2 is equal to 0, and so X equal to +2. This is the oxidation state of Fe, that is phase. So the name of Fe, K4FeCN6 is a potassium hexacyano or hexacyanide 2. We'll take one more example, and this is LiAlH4. Second example is what? LiAl and H4. So here also this is anionic complex, and your left hand side, that means ionization sphere, contains lithium. It is again metal. So first you write name of that. It is a lithium. Then you go for ligand. Now here ligand is H minus hydride, and it 4 H minus ions are there. That means it is a tetra. IDE get changed to IDO, so it is a hydrido. Then central metal atom is your aluminium, and suffix is get changed to ATE, so it is aluminate. And now oxidation number of this aluminum. What is the oxidation number? Just now I told you how to find out oxidation number of the compound. So for H it is a -1, so it is what? 4 minus ions are there, so it is a -4. For Al it is X, so X. For lithium it is a +1, so it is a +1 plus X -4, and that is equal to 0. So for Al it is 3. So write in Roman letter and enclose in the parenthesis. This is the oxidation number of aluminium. So overall name is a lithium tetrahydrido aluminate 3. We'll take one more example, and this is your another example is your Na3, then CO, then NO2, 6. Now this is also anionic complex. Why? Because if Na3 is removed, then your coordination sphere acquires negative charge here, and so it is a anionic complex. Here in this case NO2 is a ligand, and this is an ambidentate ligand. Why it is ambidentate? Because the NO in NO2, nitrogen and oxygen both can donate electron pair for the bond formation to central metal atom, but out of these two only one can donate at a time, and so it is ambidentate ligand. In this case nitrogen donated electron pair to central metal atom, that is to cobalt, for the bond formation, and so while writing the name you are supposed supposed to indicate there the donor atom. So here also first you write name of the metal, and this is your sodium now. Sodium. Then hexa. Now name of this group is a nitrite. ITE get changed to ITO, so it is hexa nitrito. Then nitrogen donating, so write N. If oxygen is donating electron pair, then it will be sodium hexanitrito O. Here nitrogen is donating, so sodium hexanitrito N. Then name of the central metal atom, and this is what? Cobaltate. Cobaltate, because the complex is anionic complex, and in anionic complex the ending name of central metal atom ends with ATE, so it is a cobaltate. And now oxidation number of the cobalt. What is it? For nitrito group, it is a -1. 6 nitrito groups are there, so it is a -6. For cobalt, it is X. For Na, it is a +1. So 3 Na plus ions are there, and hence it is a +3 plus X -6 is equal to 0. That means X is equal to +3. So write oxidation number with Roman letter and enclosing the parenthesis. It is +3. Sodium hexanitrito and cobaltate. So wherever ambidentate ligand is there, you are supposed to mention the electron donor atom also in the name. Next we'll go for example, that is CO, then Cl2, then En2 plus. So here in this case, now if you see the ligand, there are different ligands are there, and wherever this situation is there, you are supposed to use alphabetical order in writing the names of that particular ligand here. One is a chloro, that means chlorido or chloro, and another one is ethylene diamine. So in between chloro or chlorido and ethylene diamine, C comes before E alphabetically. So first you are supposed to write name of the Cl ion here. Now in this case, as it is an cationic complex, now it carries a positive charge. So first you are supposed to write the name of ligands here according to alphabetical order, and wherever the ligand contains already some number in their name, then in that case, to indicate the number of that ligand, you are supposed to use the prefixes as bis, tris, tetracis, etc. again depending upon the number of that particular ligands here. So here in this case, 2 chloro groups are there. So name is your dichloro. You can write chlorido also, dichloro or dichlorido. Then for ethylene diamine, that means in ethylene diamine already number di is there, and wherever such a situation is there, here you are supposed to use the prefixes bis, tris or tetracis depending upon the number of that ligand. So here in this case, now 2 ethylene diamine groups or amine molecules are there, you are supposed to use the prefix bis in bracket ethylene diamine, then as it is a positively charged complex, no need of changing suffix with ATE here in case of central metal atom. Whatever name of central metal atom, you write as it is with this oxidation number. So here it is a cobalt. Then oxidation number for En it is 0. It is a neutral. So for En, oxidation number is 0. For Cl it is a -1. 2 Cl minus ions are there. So it is a -2. For CO, suppose it is X, then X minus 2 plus 0 is equal to 1 plus 1. and so X is equal to plus 3, and hence oxidation number of cobalt is 3 enclosed in parenthesis. So the name of compound is what? Dichlorobis ethylene diamine cobalt 3 is the name of that compound, and this is iron, so write here iron. Positive charge is there already on the coordination sphere, so this is in the ionic form, so you can write there iron here. That is a dichlorobis ethylene diamine cobalt 3 iron. Then next will be we can see the nomenclature of cationic complex. Here in anionic complex we have seen what? First we are supposed to write name of the cation, because cation is present as a counter ion and it is present outside the coordination sphere towards the left hand side. So wherever metal is present as a counter ion, 100% it is your anionic complex, and wherever anionic complex is there, first you write name of the metal. For example, we have seen K4FeCN6 where first metal counter ion is your metal and name of that metal is a potassium, so write first potassium, then you go for name of the ligand along with the proper number of the ligand using the prefixes di, tri, tetra depending upon the number of that ligand. As 6 cyno groups are there, it is your hexa, cyno or cynido you can write. Then as it is a negatively charged complex, because negative charge is there on coordination sphere, it is a ferrate, because according to rule you are supposed to end the name of central metal atom with suffix ate, so it is a ferrate, and then oxidation number of that central metal atom write in Roman letter and enclose in the parenthesis. Then next is we have seen LiAlH4. Here H4 is your ligand and it is hydrido. Your counter ion is a lithium and it is a metal, so it is a lithium tetrahydride aluminate, as it is a negatively charged complex, anionic complex. Your name of the central metal atom ends with ATE along with the oxidation state or oxidation number enclosed in the parenthesis. So this is about the rules of anionic complex. Then we'll see the nomenclature in cationic complexes here. So let us see now IUPAC nomenclature in cationic complexes. Here rules are same as that of the anionic complexes, but some rules are different here. First, there we are supposed to write name of the metal, that is counter metal. Here you are supposed to write, wherever complex is a cationic complex, first you write name of the ligand with prefix di, tri or tetra depending upon the number of ligands here. Then next rule is what? Write the name of central metal atom with oxidation number enclosed in parenthesis. No need of changing suffix to ATE, whatever name you write as it is, only you are supposed to write oxidation number like previous one in Roman letter and enclose the parenthesis. Then last rule is, then finally write the name of an ion which is present as a counter ion outside the coordination sphere. So these are some rule used in writing or in finding the IUPAC name of the cationic complex here. We'll take one example so that it is much clearer to you. First example is COCl2. Example is your CO, then Cl2, then En2, and it is Cl. Now all the rules are same. When different ligands are there, use alphabetical order in writing the name. Wherever already some ligand or the chelate ligand contains already some number there in their name. So there you are supposed to use the prefix bis, tris or tetracis. And remaining is here in this case chloride, that means chlorido and ethylene diamine, two ligands are present and we are supposed to use your alphabetical order. So write the name of ligand first, as the complex is your cationic complex. Why? Because if Cl is removed, the whole coordination sphere acquire positive charge and Cl acquire negative charge on ionization. So it is your cationic complex, and wherever cationic complex is there, first you write name of the ligand with prefix depending upon the number of ligand here. As chloro and ethylene diamine is present, C comes before E alphabetically. So write here first name of chlorido group. So it is your dichloro or dichlorido. I'll write here dichloro, then bis in bracket ethylene diamine, or you can write IUPAC name also instead of ethylene diamine, ethane 1,2-diamine. Then next rule is what? Write the name of CMA, that is the central metal atom with oxidation number enclosed in parentheses. Here central metal atom is a cobalt, so write cobalt. No need of changing NDE to ATE. Why? Because this is a cationic complex. So write the name of central metal atom as it is with your oxidation number. What is the oxidation number here? Suppose for cobalt it is X. For Cl it is -2. 2 Cl minus ions are there. So it is X -2 plus 0, because this is a neutral ligand, plus 0. This is what? Plus -1. So overall it is X -3 is equal to 0. And so X is equal to +3. So write here +3. And finally write the name of anion. So here counter ion is an anion. So write the name of that anion as chloride. So overall name is what? It is your dichloro or dichlorido bis ethylene diamine cobalt 3 chloride. We'll take one more example, and that is CO, then Cl2, then H2O, 4, Cl. Here again two different ligands are there. One is chlorido or chloro, another one is aqua or aquo it is, and A comes before C alphabetically. So first you write name of H2. So it is a tetra aquo di chlorido or dichloro, then cobalt. Name of central metal as it is a cationic complex, so it is a cobalt. In bracket oxidation number. Then what is the oxidation number here? For Cl it is a -2, as 2 Cl minus ions are there. For cobalt it is a X, so X -2 plus 0. For H2O it is a neutral molecule, so it is a 0 -1. So here also it is a +3. Cobalt +3 chloride. We'll take one more compound, and this is your nickel, Ni, then DMg 2 H2O. Now this is your complex containing two different ligand again. One is aqua, another one is dimethyl glyoxide. And here in this case also, this is a chelate ligand which contains already the number di in their name. And so here we are supposed to use, as 2 DMG molecules are there, use suffix bis here. But before that you are supposed to write name of the water, that is di, not 2, for 2 you are supposed to write di, aquo, then bis, in bracket dimethyl glyoxime, nickel. What about oxidation number? For H2O it is a 0. For DMG, for 1 DMG it is a -1. 2 DMG molecules are there, so it is a -2, and hence the oxidation number is a 2. Write in Roman letter and in parenthesis. So this is about the IUPAC nomenclature in cationic and anionic complex. In cationic complex or an anionic complex, both the rules are same. But in anionic complex, your counter ion will be the middle atom, and it is present towards the left hand side of your coordination sphere, outside the coordination sphere. And in cationic complex, your counter ion will be anion, it is present, or non-metal, it is present towards the right hand side of the coordination sphere, outside the coordination sphere here. In anionic complex, first you are supposed to write name of the metal, then name of the ligand along with the prefix di, tri, tetra, depending upon the number of ligands here. In case of monodentate ligand, and then name of your central metal atom supposed to end with ATE along with oxidation number in Roman letter enclosed in parenthesis. Wherever chelating ligands are there and already one number is there in their name, then in that case use the suffix bis, tris or tetrakis, pentakis, etc. depending upon the number of that ligand. And in case of cationic complex, you start the name with name of ligand. IUPAC name of the complex with name of ligand. Again, depending upon the number of ligand, you are supposed to use prefix di, tri or tetra for monodentate ligand. For polydentate ligand, for chelating ligand, if already the name is there in the name of ligand, then in that case you use the prefix di, tri or tetra. If no name, then in that case you can use di, tri or tetra. Then finally you can write name of the anion. So this is about the nomenclature in cationic and anionic complexes. For example, I can tell some examples of chelating ligand in which already the name is present, like ethylene diamine, like dimethyl glyoxime, like ethane triamine. So if already name is there, in that case only you are supposed to use the prefixes bis, tris or tetrakis. Rest of all ligands you can write as simply di, tri or tetra. So this is the nomenclature of cationic and anionic complexes.